Hey, chemistry. We have two things to get through today. First is I want to talk about the questions in this lab. I'll also go over real quick the appearance and the names. I'm not going to go through all the naming stuff because we just took a quiz on it. It was on the test. You had a bunch of homeworks on it, so I'm just going to write them down. But I want to go over the stuff all the way down there. Then I want to get into talking about chemical equations because, it's been a couple months and now we can do chemistry, right? You have enough of a background now to actually start to do chemical reactions, to look at how equations take place, and how equations represent what happens in those reactions. So, without further ado, let's get over here. So, chemical names and formulas. This was page 8 of your lab manual, and this was I asked y'all to do like the top half. Now I realize in hindsight, right? Hindsight is 2020. Feels funny to say that out loud now. Uh, the top half really meant this section up here. So, like I said, I'm gonna just go through. Excuse me, and I'm gonna name. Right, I'm gonna do the appearances. So, the COCl2 were purple crystals, and it was cobalt 2 chloride. Lead 2 nitrate was a white powder, and it's Pb. Oh goodness, there we go. Pb NO3 2. Not tight. Okay. I don't know. My writing thing here is freaking out a little bit. It'd be pretty cool if it stopped doing that. Hello? What in the world is happening? Are we broken? Alright, it looks like we're a little broken, but it's okay. Let me clean that up a bit there. Alright, so Pb, parentheses, NO3, parentheses 2. Sodium phosphate was also oh my gosh, a white powder. Oh, I think I know what's happening. I think I have realized what is happening. There we go. Okay. Now we're working. Sorry about that. This was also a white powder. Chemical formula is Na3PO4. The nacho, NaC2H3O2 were kind of clear crystals / chunks. And this is sodium acetate, NaCl, those clear crystals. And this is sodium chloride, and it's table salt. Finally, CuSO4 was a blue grains / powder, and it was copper 2 sulfate. Alright, now what I really wanted to get into, I'm not going to take a ton of time, but just a little bit of time, right? What information does a chemical formula tell us? So I'll write this a little below, and let me scroll down a bit. Alright, so what information does it tell us? The composition of the compound. Right, specifically it tells us what elements it's made up of, tells us how many of each element there are in the compound, but generically, the composition of the compound. Number 2, write the symbols of all the cations and anions, including charges used in the experiment. Alright, now this is something that you may not remember, because I mentioned it very briefly. Cations are things with a positive charge. Anions are things with a negative charge. and I'm going to make a list. I'm going to start the list. I'm going to ask you to finish it kind of after the video. The first compound was cobalt-2, which means it's cobalt with a +2 charge. Chloride, which is chlorine with a -1 charge. Right? So that is the first set of cation and anion. Our second compound was lead-2 nitrate. So what that means is that I had lead-2 means lead with a +2 charge. Nitrate is NO3 with a -1 charge, right? There are 4 compounds left. Find the positive ion and the negative ion, and just make a list. Right? Then some of them will repeat. That's okay. That's not a big deal. You can have more than one of the same thing in the list, but I'd like you to do, for each compound, there are only 4 remaining, the positive and negative ion. Finish that list. All right. Number 3, following an element. So what does it mean when the number follows an element versus when it follows following, not a parentheses, just following parentheses. So when it follows an element, it's the number of that element. When it follows parentheses, it's the number of everything in the parentheses. And what I mean by that, when I have this 4 after O, then I have 4 O's. But when I have 2 after NO3 in parentheses, it means that I have 2 of everything in the parentheses. So I have 2 NO3s. All right, so that's what that means. And number 4 is really an extension of number 3. Are CuSO42 and CuSO4 two different? Yes. The first has 42 oxygen. The second has 2 sulfates, or 2 SO4s. Right. So that's how those are different, and they're going to be very different compositions. It's going to look different if you try to put them together. Also, you really can't have 42 oxygens in the same compound. It's really not going to work. Finally, number 5, when is it appropriate to use Roman numerals? Well, it's appropriate when the metal, somebody is sneezing in the next room, when the metal has more than one possible charge. Right, so when you check your reference table and you look and you see that something has more than one possible charge, that's when we need the Roman numeral to name that compound. All right. Now, when you finish that number 2, make sure to turn this in to the assignments. Ooh, there we go. What I'd like to do is move into page 28 and into page 29. We'll talk about chemical equations. Now, a chemical equation is something that gives us the recipe for carrying out a chemical reaction. Right? So chemical equations are things that we'll read from left to right. So we have something, arrow, something else. They're separated by an arrow. Right? Everything on the left side of the arrow is called a reactant, and it gets used. That's not how you spell reactant. Reactant. And it gets used up. Everything on the right side is called a product. So in the example, these are reactants. Here's the arrow separating them, and these are products. Right? The phases are things that we put in parentheses. So S, L, and G, solid, liquid, gas. AQ refers to something dissolved in water. This is also AQ implies that what we have is a mixture. All right? So just a note for future reference, because that's a very easy way to tell which of the following is a mixture. If they give you those phases, AQ. AQ is automatically a mixture, right? Now if I look at this reaction, at the example, this says that I have CH4 and O2 at the beginning, they're my reactants, and then I create H2O and CO2 at the end of my reaction, they're the products, right? Now, this equation is great, and it works, and it describes something that happens. This is combustion. This is the combustion of methane gas. So CH4 is methane gas, it's natural gas, O2 is oxygen. I combine those two in the right proportions. I get fire, I get light, I get heat. I also get water vapor and carbon dioxide, right? Now, in order to do the chemical reaction, the chemical equation has to actually be balanced. And in order to do that, we have to obey 3 conservation laws. We have to go mass, we have to go charge, and we have to go energy. Right? Now, conservation of mass means that all the mass that was there in the beginning has to be there at the end. Right? So if I had 100 grams in the beginning, I'm going to have 100 grams at the end. If I have 1 C at the beginning, I have to have 1 C at the end. Now when I'm doing this, I'm going to skip a few places here. I'm going to come down to the bottom, and I'm going to write down that reaction again here. CH4 plus O2 arrow yields, turns into CO2 plus H2O. And I'm separating it, I'm going to separate it right here. Right? And I'm going to count. I have 1 C, and I have 1 C. Right? On this side, I have 4 H's, and on this side, let me keep this on the page. Oh, hello, there we go. I have 2 H's, and over here I have 2 oxygens. Over here I have 1, 2, I actually have 3 oxygens, and it looks like I've broken things. See, my phone agrees, it looks like I've broken things. I have not broken anything, I have simply not balanced this. The way that we balance it, and I'll leave blanks here like this, because I'm talking about this bullet point, is when we balance an equation, we do so by adding coefficients, which are big numbers in front of a whole compound, and they are a multiplier. You multiply that number by everything, by each element in the compound. Right? If there's no coefficient, the assumed number is 1, but I'm going to use coefficients to fix my problems. Right? My problem right now is that I have 4 H's here, but I only have 2 H's here. So I need to multiply this H by something. If I put a 2, oh goodness gracious, if I put a 2 in front of H2O, then it changes the number of H's that I have, and it changes the number of O's that I have. If I take 2 H2O's, what I'm going to do is I'm going to take, it's going to be a little too big. Let's do that. I'm going to take this 2, and I'm going to multiply it by how many H's there are. I'm going to take this 2, multiply it by how many O's there are. So 2 times 2 H's is actually 4 H's, and 2 times 1 oxygen is 2 oxygens in this H2O, and there are 2 oxygens from the CO2. That's 4 oxygens total. So I have fixed my hydrogen problem. I never had a carbon problem, but now it looks like I have an oxygen problem. So I need to go back. I need to go back to my reactant side. I need to find, well, if I put a 2 here in front of oxygen, then that changes, oh goodness, that changes the number of oxygens right here to 4. And now I have 4 oxygens on this side, 4 oxygens on this side. And I've checked off that I have the same amount of everything, which means that this is now a balanced equation, right? It means that CH4 plus 2O2 yields CO2 plus 2 H2O, and this is my balanced equation. I have the same amount of mass at the beginning as I do at the end. I have the same number of each element in the reactant side as I do in the product side. And that's exactly what I need. Now, the last thing to look at here, right, is is you cannot change subscripts when you balance. You only change coefficients, right? So H2O, H2O2 are not the same thing. This process is what I did on the bottom of the other page, right? Now, as practice, what I'd like y'all to try, right, are these two practice questions here that are not labeled, and I'd like you to check out 1, 3, and 5. Oh, what's happening? Why can't I circle things? 1, 3, and 5. Oh, I probably ran out of space. Okay, 1, 3, and 5 down here, right? So page 29, those two practice questions there, 1, 3, and 5. Give those a shot. I will look at those first thing, and this is going to lead us into another lab. And it'll be another like semi-virtual lab. I'll do a little digital demo for you to follow along with. Until then, I will get the quizzes graded as soon as I can. And if you have any questions, let me know. Email me, alright? Take care, y'all. I will see you soon. Here we go. Almost Thanksgiving, so we're getting there. We're getting there, y'all.